A very good morning to all of you students. How are you doing these days? I hope your enthusiasm has not reduced on home learning. By now, I think all of you must have realized that it's learning, whether you do it at home or you do it in school. Yes? What's important is that you listen to what your teachers are trying to do for you, understand, and you put in your effort. Okay? Come on. So now let's begin with unit 7.1 that says acids and bases. Okay? Please open your course book to pages 90 and 91. Now since this is a new unit, I will also be forwarding a video. First, before you listen to the PowerPoint presentation, please go through the video and try to understand how much ever you can. And then let's begin. Okay, follow me as I go down the slides. Now the learning objectives for this unit, one of the part is that you have to know the different examples of acids and alkalis. And the second is that you've got to compare the properties of acids and alkalis. Now acid is a word you must have often used, right? Don't do it, this is acidic, or citrus fruits are acidic in nature. Now, let's start off in a chemistry perspective. Okay, so what are acids? We find them naturally, so they are called organic acids. We find them in the chemistry lab. Many of them are inorganic acids. In the chemistry lab, you would be finding acids like hydrochloric acid, sulfuric acid, nitric acid. These are the three common acids that you will always find. And whenever you've gone to the lab, I'm sure all your teachers must have told you, be very careful with acids. So acids, the word actually brings in some amount of fear in us, that we immediately become very conscious that we must handle them very carefully. So here I will be speaking about a few of the properties of acids. Let's begin. Acids are substances that are sour, they are sharp and tangy in taste. The moment I'm saying sour, can you imagine the raw mango or the lemon and how it hits your palate? Yes, the mouth. We all like sour food. And they are sharp. Sharp doesn't mean when you're eating it's going to cut your tongue. No. Sharp means it has a crisp taste. And tangy. Tangy is when after eating you lift your tongue up on the palate and you make a sound. Yes, that's what is tangy. Now, they can be organic or inorganic acids, as I told you before. Organic means anything that is made up from living things. Inorganic is just the opposite. It can be chemically synthesized or chemically made. Yes? Now, so if I give you the examples of lime or lemon or citrus fruits or let's say tamarind, any of these, they are organic acids. Okay? Now, if I tell you the name of the acid in lime, lemon and citrus fruits, it is citric acid. What is it? Citric acid. Now you can understand the name citrus comes from citric. Okay. Now we come to hydrochloric acid, sulfuric acid, nitric acid. These are all inorganic acids. When I say inorganic acids, that is, they can be made in the chemistry lab. Not exactly in the chemistry lab, but when you combine these chemicals like hydrochloric acid, what is there you can find out in the word? It is hydro and chloric. So there is hydrogen and there is chlorine. Well, for sulfuric acid, you cannot make out what exactly it is, but the chemical formula is H2SO4. So, what is there? There is hydrogen, there is sulfur and there is oxygen. Now, when I say nitric acid, it has again hydrogen, nitrogen and oxygen. If you see the common element in each of these acids whether it's hydrochloric acid or sulfuric acid or nitric acid, is hydrogen. So, in other words, if a substance contains hydrogen ion, that is generally an acid or inorganic acid. Again, another way of classifying acids, they could be strong acids or they could be weak acids. Now, strong and weak, obviously something that is strong would be more acidic. Something that is weak would be less acidic. The next point that's very important, it is that they are corrosive. When I say they are corrosive, means if it falls on your skin, then it will eat away your skin. So, it's very, very dangerous, and which is why in the labs also you will have the bottles of acids having a hazard label. Hazard means something that is dangerous, some situation which we are going through now. We say it's a hazardous condition created by the coronavirus. It's a hazard, very, very dangerous situation. So, it's very dangerous to use. And then again, there are two types of acids. One is dilute acid and the other is concentrated acid. When I say concentrated acid, it's like the concentrated pulp or the concentrated juice that you have. Yes. So there is too much of acid. And dilute or dilute, whichever way you wish to pronounce it, are acids when you mix the concentrated acids with water. They form the dilute or the dilute acids. Now, if acid is spilled, please remember, sometimes in life you may be facing this. You must have your knowledge handy, that whenever there is acid which by mistake, God forbid it ever happens to any of us, if it spills on our body, please wash the area with lots and lots of water. The only reason is that it will dilute the acid. Let's come to the next group of compounds, that is alkalis. Okay, now if you are clear with the acids, fine. If you aren't, please stop your presentation, stop the presentation here and go back to the properties of acids. It's very important at this stage that you are clear about what acids are. Now let's come to alkalis. This word may be slightly new to you. What are alkalis? Alkalis are substances which are soapy to touch. So that means immediately when I say they are soapy to touch, that means the soaps that we use, the hand washes that we use, are they all alkalis? Yes, they are. And never ever try, but if by mistake while washing our face, if some amount of soap or the face wash enters into our mouth, we immediately wash it with water and we get a bitter taste. Correct? They are strong and weak alkalis. Now, same as acids, they are strong, or the opposite of strong, they are weak. Now, if you have strong alkalis, they are obviously dangerous and corrosive. Okay. Now, next, we can get a chemical burn. A chemical burn is a burn which happens when some kind of chemicals come into contact with us. Alkalis can be diluted with water. The same fundamental that is used for dilution, whether it is for acids or it is for alkali. Now, what are the examples of alkalis? You have sodium hydroxide. Now look at the names. I've just given 3 examples. There are many more. Sodium hydroxide. Very clear the name says. So it has sodium. Sodium is Na. Hydroxide is OH. So what's the formula of sodium hydroxide? I have not given it to you in writing. We'll do it later on because this is just the introduction. So I just want you to know the words. So sodium hydroxide is a capital N, a small a, capital O and a capital H. That's sodium hydroxide. When it comes to potassium hydroxide, it is a capital K, a capital O and a capital H. Calcium hydroxide is a capital C, a small a, capital O and a capital H. It's very important that you know which is small and which is capital. That comes in the naming of the elements, which you would be doing in grade 8. Okay, so let's come back to the similarity. What's the word that is similar here? Hydroxide. That means every alkali will have a hydrogen and an oxygen combining in the ratio of 1:1 to form hydroxide. So we have sodium hydroxide, potassium hydroxide and calcium hydroxide. If you remember, let's go back to the metals and the non-metals in one of the previous lessons that I told you. Sodium, potassium, calcium are all metals. So on which side of the periodic table do we find them? Oh, I forgot. I can't get an answer from you. So it's found on the left-hand side of the periodic table. Okay, now, so you can find out the kind of similarity that both strong acids and strong alkalis are dangerous. Both strong acids and strong alkalis are corrosive. And now we come that acids and alkalis are chemical opposites. Okay, chemically they are opposites. So, when they are opposites, they will obviously cancel each other when mixed. It's same as you have +5 and -5. When you put them together, it will be 0. So, the same principle that when acids and alkalis are mixed together, we will do it in the next lesson of neutralization. Neutral means 0. You can take it from living examples also in life's examples. They will cancel each other when mixed. There are a few safety rules, however, that we need to follow. What is it? To handle the chemicals, whenever we are handling chemicals, and this you must keep it throughout your life very clear in your mind. That when you're working in the chemistry lab, please stand up to work. You must be seeing in the chemistry lab that we go also, that the table is at a height where it's not really very comfortable to sit down and work. And it is not advisable also. The reason why you must stand up to work is that the chemicals, by chance, because we are all students and sometimes the chemicals can react suddenly, or you could do some mistake while, or even I could do a mistake while, doing an experiment. So if we are sitting and if there is an explosion of it, or if something spurts, it will come directly to our eyes. When we are standing, the chance is minimized. You must always wear safety glasses. It might look very funny or it might look very small, like just how we are washing our hands continuously, although we don't do. Maybe your parents must have told you this innumerable number of times. But see now, a virus that we cannot see, because of that, we are made to learn our basic rules. So wear safety glasses. Take the top of the lid. So when you open the lid of a bottle and when you place it down, don't place it down straight, place it down upside. The reason is that there is no dirt that you pick up when you put back the lid. Replace the bottle top immediately. As soon as you finish, please replace the bottle top. So I hope it's very clear. Now question number 1 to 4 is for homework. Now all these homework questions, I will be solving it for you after a week, so that I hope that you are able to solve them. The first, it's very simple, okay? And just get back to me in case if you have any difficulty, and I'll be more than happy to help all of you. I have a small request. Many of the students are doing it. I would like to get a much better response. Come on, just about half an hour each day. Not very difficult, isn't it? Yes, we can all do it. We can all conquer, and the world is going to win against this coronavirus. We'll all be back to work very soon and lead our normal lives. Until then, stay safe, keep praying, and let's fight it out. Thank you.